We introduced 2B method last week. You may have a love and hate feeling for this method. We love it because of its universally applicability, and as it's troublesome, we hate it. For a circuit with 6 branches, we need to formulate 12 equations. In the lectures of this week, first we will introduce the viewpoint of equivalent. You can solve circuits easily using it. The equivalence is certainly not only a tool of solving circuits. Understanding of the equivalence will help you to deepen the knowledge of the circuits. Let's get started. Here we will introduce the first equivalent transformation, that is the serial parallel connection of the resistors. Before discussing serial parallel connection of the resistors, we need to have a general introduction. First of all, a two-terminal network, we can draw it like this. These are two terminals. It might include independent sources, dependent sources, and resistors, etc. Then we will discuss a lot in this lecture about two-terminal network without independent sources. That means in the network, there may only be resistors or dependent sources. For such a network, we usually represent it with P. Today, we will discuss an important topic. For any two-terminal network without independent sources, it can always be equivalent to a resistor. Therein, the resistor is equal to U over I. So we have a vital discussion for the equivalence here. What we call the equivalence refers to the equivalence of two subcircuits, such as this and that. Their port voltage-current relationships have the same form and parameters. Specifically, for subcircuit 2, its equation of port voltage current is like this. So for port 1, we can write U equals something times I, where the something is this Req. We will discuss the concept again and again in this lecture. This concept is essential discussion for concept of equivalence.